So our next video will focus on the third laws of the exponents. It is called power of a power rule. Okay, so power of a power rule, or this is expressed in this form: x to the power m and then raised to a power n. So if you're given something like this, then we can rewrite this as x to the power. You just multiply the two powers or the exponents. So m times n. So that's our rule number 3, power of a power rule. For example, so if you are given something like x to the power 3 raised to power 3, so this is the same as x to the power 3 times 3, or equal to x to the power 9. So this is by the use of this rule, so you can get the answer immediately. Alright, and if you want to do this using the long method, applying the basic concept, so this can be solved like this. Alright, so this means that x to the power 3, it means that you have 3 x's, or 3, there are x multiplied 3 times itself, no? So we have x times x times x. So this is what is meant by x to the power 3. Alright, and then we have another power outside, so we have something like this. Then again, applying the concept, we can rewrite this as x times 3 times, x times x times x, and then there are 3 of them. So x times x times x, and x times x times x. Alright, so this is what is meant by this one. We have 3 x's in the quantity, then raised to power 3. It means that this x's, 3 x's in the quantity, there are 3 of them. And then when you remove the sign of grouping, the parentheses, so this can be written as x times x times x. This is what is inside this quantity. And another x times x times x. This is what is inside this quantity. And another x times x times x. This is what is inside this quantity. Alright, then applying the rule number 1. So the common base is equal to x, right? And then each of them has a power equal to 1. So understood to have a power equal to 1, or exponent equal to 1. So the rule is you just simply add all the powers. Okay? So we have 1 plus 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 1, or just count how many x's we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is power 9. Okay? So the same as what we have above, right? But this is the long method, and this is the shortcut using the rule. Okay, if you have, say, x to the power 4 raised to power 2, so this is the same as x to the power, you just multiply the powers or the exponents. So 4 times 2, or equal to x to the power 8. Or we can do the same as this. So we can rewrite this as x to the power 4 raised to a power 2, which is the same as x to the power 4 times x to the power 4. Okay? And then using the rule number 2, so we can rewrite this as x to the power, they have the same base, copy the common base, and then add the powers or the exponents. So we have x to the power 8. Okay, so same as this. Alright. Or using the long method, we can also do like x to the power 4 raised to the power 2, which is equal to x to the power 4 means there are 4 x's multiplied. Alright, then raised to a power 2. And this is equivalent to, we have 2 quantity with 4x being multiplied. Something like this. So this is what is meant by 2. So there are 2 of them multiplied. X times x times x times x. And when we remove the sign of groupings, the parentheses, so this becomes like this: x times x times x times x. This is inside the quantity. And another x times x times x times x, which is inside this quantity. And again, using the rule number 1, you just copy the common base, and then after that, because we know that they have exponent 1, each of them, and or simply count how many of them: 1, 2, 3, 4, 5, 6, 7, 8. Or it's the same as 1 plus 1 is equal to 2, plus 1 equal to 3, plus 1 equal to 4, plus 1 equal to 5, plus 1 equal to 6, plus 1 equal to 7, plus 1 equal to 8. So this is x to the power 8. So these are the different ways on how to solve this one. Okay, so if you see them, they are just the same, right? But the quickest way to solve this is to apply the law. Okay, so this is our rule number 3 of the laws of exponents, power of a power rule. That's all. If you have any question, just leave your question or message in the comment section below. Thank you very much.